Hello amazing people, my name is Shreya Kadapgaonkar and here's our another video. So today we are going to learn about security approaches in cryptography network services. As we know, securing digital communication is vital for online privacy and trust. This presentation explores key cryptography methods that protect data in network services. Let's see some cryptography fundamentals. There are two fundamentals, that is symmetric key and asymmetric key. What is symmetric key? Symmetric key uses same key for both encryption and decryption. The examples for symmetric key are AES and DES. What is AES? AES stands for Advanced Encryption Standard and DES stands for Data Encryption Standard. AES, it is used in banking apps, Wi-Fi security, VPA2, VPA3 and military grade encryption. The key size for advanced encryption standard are 128-bit, 192-bit, 256-bit standard. What is DES? DES means data encryption standard. It uses 56-bit key, now insecure due to brute force vulnerabilities. It is replaced by advanced encryption standard. It uses 56-bit, now it is outdated. A real life example of symmetric keys are WhatsApp uses symmetric encryption to encrypt the chat content. What is asymmetric key cryptography? It uses a pair of public and private keys. For example, RSA, that is Reverse Shamir Edelman. It is popular for secure data transfer. Means it is widely used in digital signatures, that is SSL, TLS and secure email PGP. What is ECC? It stands for elliptic curve cryptography. It requires smaller keys with strong security. It is efficient for mobile devices. A real life example of asymmetric key: when you visit a secure website HTTPS. RSA and ECC is used in SSL handshake. Next we will see hashing algorithms in security approaches of CNS. First, one-way function means it converts data to a fixed length hash value, not reversible. It generates a fixed size hash for data fingerprint. Next are some common hashes or common algorithms. SHA-256, it is used in the blockchains like Bitcoin, SSL certificates, etc. MD5, it is insecure but still found in legacy systems. What is the purpose of hashing algorithms? It ensures data is not modified in transit. Integrity. A real life example of hashing algorithms: software downloads often include a SHA-256 hash, so users can verify file integrity. Next, we will see the steps for digital signatures. First, sender signs. Second, message sent. Third, recipient verifies. And at last, integrity is confirmed. How it works: sender creates a hash of the message. Hash is encrypted using the sender's private key. Recipient uses a sender's public key to verify. And last, ensures sender authenticity and message integrity. The purpose of this is it confirms the message authenticity and verifies that data was not altered. Real life examples of digital signatures is e-Aadhaar from UIDAI uses a digital signature to verify the authenticity. Next, digital certificates and PKI. PKI stands for Public Key Infrastructure. Digital certificates: electronic document proving ownership of a public key. Its standards are X.509, which is most commonly used. Public key infrastructure: framework for managing keys and certificates. Certificate authorities: trusted entities like DigiCode, Let's Encrypt, etc. It issues and revokes certificate. Real life example of digital certificates and PKI can be when your browser says connection is secure, it has verified a digital certificate via public key infrastructure. Next, we will see cryptographic protocols in network security. It consists of SSL and TLS, SSH and VPN. We will see one by one. SSL stands for Secure Socket Layer and TLS stands for Transport Layer Security. It encrypts communication between client and server, used in HTTPS, email, online shopping, etc. Its examples are Amazon, Gmail and online banks use TLS. Next is SSH. It stands for Secure Shell. Securely accesses remote systems. Encrypts all traffic between client and server. Example, system administrators use SSH to manage Linux servers remotely. What are VPNs? VPNs stand for Virtual Private Network. It encrypts all the internet traffic between a user and a remote network. It uses IPsec or SSL for tunneling. Example of VPN, employees working from home use VPNs to access corporate network securely. Now we will see some interview questions that may be asked. First is, what are key principles of network security? Like confidentiality, integrity and availability. Confidentiality ensures data is only accessed by authorized individuals. It uses encryption and access control. Integrity, it ensures data is accurate and unchanged. Uses hashing and digital signatures. Availability ensures systems are up and running when needed. Protected using redundancy, load balancing, DDoS protection. Some another key principles of network security can be authentication and authorization, which verifies users' identities and grants access based on rules. Next, non-repudiation ensures a sender cannot deny sending a message, achieved through digital signatures. Next question can be asked, what are some key network security threats and how can they be mitigated? DDoS attacks overwhelm systems with traffic. Mitigation, rate limiting firewalls, DDoS protection services. Next is malware. Means virus, worms and trojans infect systems and steal or corrupt data. Mitigation, antivirus, regular updates, sandboxing, etc. Unauthorized access, hackers gain entry into systems. Mitigation, firewalls, strong passwords, 2FA. Another common threat can be phishing attack. Trick users into revealing sensitive data. Mitigation, users training, email filters, domain monitoring, etc. Can you explain the role of firewalls, VPNs and encryption in network security? Yes, firewalls it filter traffic entering, leaving the network, and force access of policies based on IP port protocol. VPNs, that is virtual private networks, encrypt internet traffic between user and network. It provides secure remote access, often using IPsec or SSL. Encryption converts data into unreadable form unless decrypted, used in HTTPS, emails, file storage, etc. Next question, how do you ensure secure remote access to corporate systems? Multi-factor authentication combines passwords with OTPs, biometrics or tokens, use VPNs, device management and zero trust architecture. Next question, what are some best practices for securing wireless networks? Use strong encryption, VPA3 preferred, MSC address filtering, change default SSID and admin credentials, disable SSID broadcasting, makes the internet less visible to attackers, and network segmentation. Next question, how do you implement access controls and user authentication in a network environment? Role-based access control, user authentication methods, access control lists, audit logs and permission reviews, where regularly track and update access rights. In this way, we can implement access controls and user authentication in network environment. Next question, can you discuss the importance of security monitoring and incident response planning? Yes, security monitoring, it detects the suspicious activities in real time, uses SIEM tools, IDS, IPS, log analysis, etc. Incident responsive planning and benefits are faster response, reduced damage, compliance, reputation, protection. Incident response planning, it steps to identify, contain, eradicate, and recover from breaches. It includes playbooks, response teams, and communication plans. Next question. What are the key compliance requirements that organizations need to consider for their network security? GDPR, that is EU, protects personal data, uses encryption, maintain access control, perform audits, monitor systems, report breaches as required. PCI DSS ensures safeguard payment handling. ASOX, NIST, CCPA, and other compliance frameworks. So this was all about security approaches in CNS. Hope you guys understood. Please make sure to like, comment, share and subscribe. Thank you. We will see you in the next video.